There's an auto dealership. They collect information on the number of SUVs they have sold over the last 4 years. For example, in Q1 of 2010, they sold 23 SUVs, and in the fourth quarter of 2013, they sold 43 SUVs. Based on the information they've collected, they would like to come up with a good forecasting model to predict future SUV sales. To that end, we prepared a list of 7 questions. First, we would like to use a 2-period simple moving average method to predict sales for time period 3 to 16, and then we're going to calculate MAD, MAPE, and MSE. And we're going to do similar things using some other forecasting methods as well. For example, 2-period weighted moving average, simple exponential smoothing method, additive seasonality model, double exponential smoothing model, simple linear regression model, and in the end, we are going to compare their MAD, MAPE, and MSE to determine which forecasting methods mentioned above fits the data we collected over here the best. To answer each of those 7 questions, I prepared a separate worksheet for each of those 7 questions. For example, for the first question, simple moving average method, I prepared a separate worksheet over here. For additive seasonality, for example, I have another separate worksheet prepared over here. And you see over here, I have all the formulas typed here. In the end, I have a summary table in order to compare all those 6 forecasting methods mentioned in question 1 to question 6. Okay, let's look at first one, simple moving average. Here we are going to use 2-period simple moving average method to predict sales for time period 3 to 16, and then calculate MAD, MAPE, and MSE. Alright, why time period 3 to 16? Here's the thing. Because we're going to use 2-period simple moving average, as a result, the very first time period for which we can make a forecast is time period 3, because we are going to use the information from previous 2 time periods to make a prediction. So let me start over here. Simple moving average is really simple. Okay, we're going to make a forecast for time period 3 first. It's going to be the average units sold in time period 1 and 2. Because here we're talking about SUV sales, the numbers have to be integer. So we're going to use a function called round. Okay. Round the average sales of time period 1 and 2, and we want integer, so decimal place is 0, return. So we predict that based on 2-period simple moving average model, the SUV sales will be 24 in time period 3. And since we have the formula built in this cell, we can make prediction for all the other time periods similarly by dragging it down. You see, we have the prediction created by using 2-period simple moving average. Of course, if we are looking for, say, a 3-period simple moving average, we are going to start our first forecast with time period 4. So here we're going to have formula is average of SUV sold in time period 1, 2, and 3. But here we're going to stick to a 2-period simple moving average. Once we created forecasts for each of those 14 time periods, we are ready to calculate forecast error. E stands for forecast error. It's obvious that we have no forecast for time period 1 and 2, so there will be no forecast error for time period 1 and 2 either. The first forecast error is nothing but the actual sales minus your predict sales. D7 minus E7 in my case, return. Okay, the forecast error is 12. Okay, we underestimate the SUV sales by 12 SUVs. In G column, we're going to calculate AD, which means absolute deviation. It's nothing but the absolute value of forecast error. Well, of course, the first forecast error is positive number, so first AD is equal to forecast error in this case. Next, in H column, let's calculate APE. It's absolute percentage error. Here's how we're going to calculate that. It's equal to the absolute deviation divided by the actual sales. Return, we get absolute percentage error. In this case, we know what? The forecast error is about 1/3 of the actual sales. Another way to do that, APE is equal to absolute value of forecast error divided by actual sales. Either way, we get 33.33%. In I column, we're going to calculate squared forecast errors. Here I use notation E squared. So it's going to be equal to forecast error squared. Okay. Here I have formulas prepared for calculating forecast error, absolute deviation, absolute percentage error, and squared error. And then I'm going to copy and paste to generate information for all the other 13 forecasts. Here we go. And you may wonder, why do we want to calculate forecast error, absolute deviation, and so on and so forth? Well, the answer is straightforward. We would like to calculate MAD, MAPE, and MSE. MAD is nothing but mean absolute deviation. From its name, we can pretty much tell how to calculate MAD in this case. It's going to be equal to the average of all those absolute deviations we calculated earlier. Okay, let's take an average of that return. Okay, so we know MAD, mean absolute deviation, in this case is about 8.43. Next, let's calculate MAPE, mean absolute percentage error. It's going to be what? The average of all those APEs we calculated earlier. But we want to convert them into percentage, so we're going to do something like this, times 100, return. And the meaning of this number is, on average, the forecast error is about 22.98% of your actual sales. In the end, we're going to calculate mean squared error. No surprise, it's going to be equal to the average of all those squared errors. Now we're done with the first question. First, we come up with forecasts based on 2-period simple moving average model, and then we calculate MAD, MAPE, and MSE. Next, we're going to move on to weighted moving average forecasting method. Once again, I prepared a separate worksheet to answer our question 2. Find the optimal 2-period weighted moving average model to predict sales for time period 3 to 16 and calculate MAD, MAPE, and MSE. Alright, here we are using 2-period weighted moving average. So we're going to have two weights, W1 and W2. But we don't know what's going to be the optimal value for W1 and W2. All we know is, okay, the sum of those two numbers got to be 1. Well, of course, W1 and W2 got to be non-negative. What can we do? So we're just going to pick a starting point for ourselves. For convenience, let's say W1 is 0.5, W2 is also equal to 0.5. And if you want, you can use 0.4 and 0.6 or 0.2, 0.8. And in the end, we're going to get the same number anyway. Alright, let's say W1 is 0.5, W2 is also equal to 0.5. How are we going to make forecast? The first forecast we're going to make is for time period 3. And once again, it's 2-period moving average. We cannot make forecast for time period 1 and 2 because we don't have enough information for that. So we're going to start with time period 3. It's going to be equal to W1, and I'm going to use absolute sale reference by adding two dollar signs, times the SUV sales in time period 2 plus W2 absolute sale reference times the actual sales of time period 1. What we're doing over here is to use the sales from the two most recent time periods to make prediction for the current time period return. Okay, so we get the forecast is 24 SUVs for time period 3, and we want to once again make sure those forecasts are integer. Another way to do that, let's select all the 14 forecasts we're going to make, right click, format cells. Okay, we want the numbers, right? Decimal place is 0. And here I recommend that you use this way to make sure those forecasts are integer instead of using the round function I introduced earlier. The reason is that later on we're going to use solver to find the optimal W1 and W2. If we use round function over here, it may cause some error message. Okay, 0 decimal place, that's all we want. Okay, and similarly we can find forecast error is nothing but actual sales minus your forecast, and the absolute deviation is nothing but absolute value of your forecast error. APE is absolute value of forecast error divided by your actual sales. In the end, squared error is nothing but forecast error squared. Once we have all those formulas prepared, it's easy to do the same thing for all the other 13 forecasts. Here it is. Okay, and we're going to calculate MAD the same way we did earlier. It's average of all those absolute deviations, and MAPE is the average of all the APEs times 100. In the end, MSE is the average of all the squared forecast errors. And probably you remember that those three numbers were identical to their counterpart in simple moving average. It shouldn't be a surprise because W1 equals W2 equals 0.5. That means time period 1 and 2 carries the same weight, and it gives you our nothing but the simple moving average. All right, now here comes the more interesting part. We start with 0.5 and 0.5. We just randomly chose those two numbers for convenience. Okay, it could be anything, but the thing is, those two numbers might not be the best. What do you mean by that? We can choose those two weights wisely so that the mean squared error will be minimized. How to do that? We're going to use solver, which we introduced in linear programming part to get the job done. Let's select Data tab, click Solver. Let's reset all. Okay. Our objective is MSE in cell H24. We would like to minimize it by doing what? By changing our W1 and W2. And constraint would be the sum of the weights gotta be equal to 1. That's it. And we check this box to make sure W1 and W2 are non-negative. And here, be careful, we're going to use GRG nonlinear method, because in MSE we have what? Squared errors. We have square terms. So a better way to do that is to use nonlinear method. That's it. Let's click and solve it. Keep our answer. What do we find? The optimal W1 turns out to be 0.8229, and the optimal W2 turns out to be 1.1770. In the end, MSE is minimized. The smallest MSE we can possibly get is 102. And based on that, we can tell already that in this case, this optimal two-period weighted moving average method is better than the simple moving average we introduced earlier. Because it doesn't matter which number you want to look at, MAD, MAPE, or MSE, this optimal two-period weighted moving average method always gives you the lower numbers over here.